Hello. Many people ask me, why is the relative atomic mass of chlorine actually 35.5? It's weird that it should be a 0.5 number. It is. It doesn't mean that it's got half a neutron or half a proton. It doesn't mean that. It's all to do about its isotopes and the abundance of all the isotopes of that chlorine. So for example, the relative atomic mass of an element is the weighted average of the masses of the atoms of the isotopes. So it's all of them. So there is a brilliant calculation to help you work this out, and it's one that you're going to need for your exam. So let's look at chlorine. There are two isotopes of chlorine. Chlorine 35, which means it's got 35 protons and neutrons in its nucleus, and chlorine 37, which has 37 protons and neutrons in its nucleus. The abundance of this one is 75%, so there's far more of this isotope in our atmosphere and in our world than of this one. It's only 25%. Now to calculate this, it's quite an easy calculation, but it's one you do need to remember. We need the mass of our first isotope, so mass of the first one, times its abundance. Oops, spelling that wrong. Added to the mass of the second isotope times its abundance. Now if you had 3 isotopes or 4 isotopes, you would continue on doing this for every single mass and abundance. Now because we want this, we're going to divide this by 100, because obviously our abundances are as a percentage. So for example, for chlorine, we actually have 35, which is our mass. We then have 75, which is our abundance, and we're going to add that to our 37 plus the 25. So overall, that equals 2,625 added to 925. So those added together will equal 3,550 divided by 100, which will equal the 35.5. That means this is the average abundances of any of those two isotopes. This works out for all of them. So if you tried this with any of the atoms in the periodic table that have isotopes, the one difference is chlorine's only got 2 isotopes. Many have many more. You would just continue the process in exactly the same way.